In tonight's video, we're doing our second part of inequalities, in which we're going to solve linear inequalities, both simple and compound. And it has the same idea as solving an equation, except with an equal, instead of an equal sign, we're going to have an inequality symbol. In our first example here, we have a very simple linear inequality in one variable, and so our goal is to get x by itself. I'm going to draw a line to separate the two sides of my inequality, and I'm going to solve it just as I would a regular equation. So I'm going to begin by getting my like terms together, and I have x's on each side that I need to get together. So I subtract the 2x, doing the opposite operation of adding over here. And so I get this, bringing down the negative 3. And then my next step would be, I would subtract 7 from each side, because 7 is a like term with a negative 3, which gives me 2x is greater than or equal to negative 10. And my final step would be to divide both sides by positive 2. Now in this case, since I'm dividing by a positive 2, the inequality symbol here will not change. And so my final answer is x is greater than or equal to negative 5. Now sometimes this answer needs to be reported in different formats, so we can report this solution set in this way: all x's such that x is bigger than or equal to negative 5. Or if we're using interval notation, which we talked about in the previous video, we would write it in this way: negative 5 is included in every x infinitely. And remember, whenever we use the infinity symbol, we have the open notation here, because infinity can't be included. Next, we're going to do a compound inequality example, and our goal with compound inequalities, when they're written in this format, is to get the variable by itself in the middle of the inequality. And so my first step in doing this here is to get rid of this 2 in the denominator of the fraction. And so since this is division by 2, I'm going to multiply each part by 2 in order to get rid of that 2 there. So here I've written it out where you can see multiplying by 2 in each step. And so what I get here on the left side of the inequality, and I should probably draw you the lines to determine the sides of or the parts of the inequality, I should say. Okay, so 2 times negative 1 gives me negative 2, less than or equal to. Remember, these 2's are going to go away, and I have 3 minus 5x in the middle is less than or equal to 18. So now all I need to do is to get rid of this positive 3 and this negative 5. So to get rid of the positive 3, I'm going to subtract each part by 3. And so subtracting each part by 3, I get negative 5, negative 5x, and 15. And so my final step will be to divide by that negative 5 in the middle. Now since I'm dividing by this negative 5, as we learned in the previous video, my inequality symbols are going to change directions. So this is 1 is greater than or equal to x is greater than or equal to negative 3. Now to write this final answer, we always want to report our inequalities with our smaller number on the left and our larger number on the right. So I'm just going to rewrite this as negative 3 and 1 here, but remembering to keep the symbol as it points toward the number. So for instance, the negative 3, the symbol is pointing towards it, so I need my symbol to point towards negative 3 here. Same way with 1, it's open towards 1, so I need it open towards 1 there. And so what this solution set tells me is that x can be any value in between negative 3 and positive 1. And so on the next slide, I'm going to show you the interval notation for this, as well as a solution set notation for this, and a graph. Alright, so here we have our answer as a solution set and an interval notation. And so this just says x such that x must be bigger than negative 3 but smaller than 1. And then this is our interval notation we learned yesterday. We use the bracket instead of parentheses because we have the equal to part on our inequality symbol. And we need to really get in the habit of using interval notation because that's what we need to practice on at this time. For this particular problem, we're going to start first by getting rid of this negative exponent. And using the properties of exponents, that becomes 1 over 4x minus 1, which is greater than 0. And now the reciprocal property that we did not speak of in our previous video says the following. It says that if 1 over a is bigger than 0, then a is also bigger than 0. I should put if here. So that's the reciprocal property. And so what that tells me is that I can say, since 1 over 4x minus 1 is bigger than 0, I also know that only 4x minus 1 is bigger than 0. So it becomes this. And that is because of the reciprocal property. And so from that point, I would solve this like I would the very first example that we did today. I would add 1 to each side, change colors here. And that gives me 4x is greater than 1. Divide by 4, so x is greater than 1/4. And now we haven't been graphing each of our solutions, but we do need to do that also. So since we talked about in the previous video, just to remind you here at the end, this one would look like this. Here's my graph for this particular inequality solution. And if I wanted to write this in interval notation, it would be an open notation, 1/4 to infinity open notation. And that takes care of our inequality video for this evening. See you tomorrow.